G'day people, as promised, an update on the power supply. Okay, first things first, accuracy of the meter, 0.738, 0.738, can't really disagree with that. The set switch for the meters removed, as I pointed out in the last video very quickly. It's done off this switch now, so when it's in 2-wire mode, the meter's measuring 2-wire mode. When it's in remote sense or 4-wire mode, it'll be reading 4-wire mode. At the moment, I've got a few other things to go into, but first, I just want to point out the problem I've got with this meter. It's only a 3-wire meter. Now, I've found some 4-wire meters online, but the microcontroller that this has is a genuine ST part. Has the numbers and badge and everything on it. Looks original. Panel meter's made by Ryden. The other ones online, the 4-wire ones, they appear to have like an op amp and a trim pot and another reference or something on there. I'm assuming to get a differential input separate to the power lines for the 4-wire measurement. I'm not sure about the quality on them. What should be ST chip micro, it is sanded. There's no numbers on it. The op amp is also sanded and has no numbers on it. If it's an op amp, I don't know. The accuracy in the specs seems lower too, so I'm a little bit hesitant to try those. I want to come up with a solution for this. So I'll show you the problem that I've got with this. Right now, it's getting its positive rail that feeds its voltage off of a 12-volt regulator over here. Now here's where it gets tricky. Because it's only 3 wires, its voltage measurement is referenced to its negative wire. So if I was to power it from, say, negative over here, as you get a negative voltage drop on here or here, depending what mode the supply's in, the panel meter's not going to see the negative voltage drop. Might see a little bit as the transformer voltage sags, but it's not going to see the drop in the wire and the terminals and everything. It's going to be out by millivolts, tens of millivolts, maybe even 100, I don't know. Probably tens. So therefore it needs its negative wire to be powered, basically not from the negative output or the remote sense output, but from the switch, the out point of the switch. So, like the negative from when it's in 2-wire or the negative when it's in remote sense. Problem with that is, if I just take a negative wire and hook it up to where this goes, the negative wire from the 2-wire, 4-wire switch, my waveform gets noisier by about 20 microvolts RMS and 100 microvolts peak to peak. It's also 1 millivolt less accurate. So that's only the 1 millivolts just because of where I've moved it. If I actually mount it closer to the front, as close as I can get it, yeah, still noisy. So, as I've mentioned, I don't want to really, I might try the other meters, order them, see how they are, but I don't really want to. What I would prefer to do is, I had 2 theories. One was to take the positive sense wire, the one that is actually isolated from the supply, floating, and put a voltage divider on it. between the negative off of the switch and the positive off of the leakage sense resistor. And put the voltage divider between ground and positive, like after that switch, so that the meter still sees the difference between both the terminals. The problem with that, I was hoping the meter would be out, like read over, or have a trim pot on the back of it that I could make it read a little bit higher, because the resistive divider is going to bring the voltage down. So then it wouldn't be displaying the true output. I could modify it. You know, there are resistors on. There's a resistor on the network, resistor divider network on the back of it. I could trim that. I could still do that, but I've got a more elegant option. That is, sorry, I've got a whole load of cats in my house and 3 kittens, and they're going through everything. Can you get out of there, please? Hey, come on. Come on. Go on. Get out. Hey, I'm trying to record a video. Come on. Sometimes it's best to just shut the door. Right. As I was saying, the solution I propose, our most accurate point to measure is this end of this black wire here on the back of this switch for the panel meter's negative. How I'm going to do that without injecting noise in there, because that's the problem. The panel meter is powered between positive and negative, but it's also using negative as a reference. So there's a low impedance path between positive and negative, allowing common mode noise that's like halfway rectified, sort of, to go back in to the driver circuitry. So what I propose to do is buffer using an op amp this point here, and then run this off the op amp. That way, I'm hoping that I can, you know, get my accurate 4-wire and 2-wire measurement on the panel meter, proper accuracy. Actually, could even improve the accuracy, because the op amp I'm going to use is actually trimmable. It's got offset pins, so that's handy. You can trim it up or down. So I'm going to buffer the negative rail, the negative sense rail, and power the panel meter from that. And then not only will it be buffered, but it will be trimmable. I'll be able to add some resistance to the input of the op amp if it still introduces a bit of noise. I'll be able to chuck some resistance on there, put a capacitor after it, build an RC filter up, and that should knock out the noise. Obviously, I'll want very small values, because I don't want the panel meter's time to be slowed down, like the read back time. I want it to be nice and fast. But yeah, so that's what's going on with the panel meter. Not much has changed in the last few days. I've experimented with a few different things, and I've worked out that I'm going to buffer the negative rail, basically, or the negative sense point. Things that have changed, there are a couple of, what are they, 400 volt, 1 microfarad, what class are they? They're 400 volt MKTs. going to a 100 ohm resistor, going to a wire, going to the star grounding point. So that star grounding point goes to the case, to the transformer, to the mains ground, and then to that 100 ohm resistor, to those two caps that go across the output to get rid of all the common mode. There's another big fat black ground wire that goes to the ground terminal, goes straight back to the star ground also. There's another wire there that also goes back to the star grounding terminal, which goes to the front panel. Originally I had that just linked down to that ground there, but I wasn't happy. I want proper star grounding. The transformer, basically, not really a transformer, but this transformer's bolted to the case. It's still soldered and tied down to the star grounding point there, and it's bolted to the back of the case. These thick bits of metal on the side, that's fine. The side parts of the case make electrical contact through these screws. I've made sure there's no paint where they go in so that they make really good contact. So the entire case is one big shield. It's star grounded, well, the front panel. And let me just point out, the reason why I've had to ground the front and back panels is because they're painted. You've got the chance of let's say a little metal tab in there scratching, through the paint and connecting the panels together. But if you want to rely on that for grounding, you might as well be producing stuff in China. I need this to be proper. If 10 amps, 240 volts hits this panel, I don't need wires melting, I don't need smoke, I don't need stuff not tripping. I'd like it to just go straight to ground. Okay, so star grounding sorted. I did actually take the negative wire that goes to the output and wrap it around the positive wire that goes to the output, just to sort of shield it, and around the positive wire that goes to the load resistor. Doesn't really have too much of an effect, but why not? Funny thing, I might actually unwrap that and just run it straight alongside it, because having it straight alongside it, it'll still be coupled to the red wire, the positive, but without the twisty, it'll have a lower inductance, which will provide better feedback for the power supply. So that's what's going on with that. Now, the driver board, that's literally just an experimentation board that's going to come out and get made up, as like a final board. Like all these other boards. These are all finals. Let me just get something to point with. On the positive rail input to the driver transistor and the pre-driver transistor, well, two pre-drivers, because that tip 41C drives these two SC5200s. But anyways, these two transistors had 8.1 microfarad bulk, if you want to call it bulk, cap on their positive rail going to ground, just so that, when a huge spike comes out of this cap bank, these two small transistors don't see as much of it, if any at all, with the small resistance of this thin wire and the inductance of it, and a decent sized cap that'll actually knock off sharp spikes and they won't see it. I had a 0.1 monolithic cap there. It was only rated for 50 volts. When this is on the 38 volt winding, the rectified output's like 52, 53 volts. I forget what it is, but that was the spec. I've swapped it out for a 100 volt cap, and I've gone with an MKT because the ESR on this is extremely lower compared to the monolithic ceramic, even though that's got a low ESR compared to, say, like a standard ceramic. This has got a really good low ESR at lower frequencies, and the ESR only gets smaller all the way up in frequency. Unlike some caps like electrolytics, where you go up in frequency and the ESR all of a sudden starts to rise, the ESR just smoothly drops all the way across the board, basically. The beauty of it is most caps that do that have a higher ESR down at low frequencies. This one does not. So I've chosen a 1 microfarad instead of a 0.1. Good ESR value. 100 volt. It's on a 53 volt rating. 100 volt rating also helps with the ESR. Higher the voltage rating, better the ESR, I think. I could be wrong on that, don't quote me on it. Anyways, that's what's going on there. There was a diode across the collector and emitter of this transistor. I can't remember why I actually put it there. I might have smoked this transistor a few times, doing testing or work on it, and put it there to stop some voltage going across it, but it doesn't really make sense to me because it would only be putting the voltage into the base of this transistor. So I've got to have a think about that and go back over my notes. It might be something to do with feedback, I'm not sure. I don't think so, I can't see how, unless it's to deliver a bit of a spike, if there is one into here, but it's not going to be inverted through 3 transistors by the time it gets to the output, so that doesn't really make sense. So yeah, I removed that diode. Over here between the base, and the driver transistor's been changed from a low noise BC550 to a standard BC546. There's no difference in the noise figures on the power supply's output with the 2 transistors, but this one has a lower VCO, VCEO, the voltage between the collector and the emitter, it's lower. I think the VBE is lower too, so that's good because the power supply can go down to a lower voltage. It also has a higher HFE, so it's about the same, the HFE on this one. It's got a higher voltage rating. So the reason I've done that is because the collector to emitter voltage, I think it's 65 or 80 volts, and the base to emitter junction's 45 or 65 volts, and the VEBEO, which a lot of people don't get, that's the voltage between the base and emitter, but the reverse voltage that will cause the transistor to break down. The BC550, it's 5 volt, this one's 6 volts. I know it's only a volt difference, but when this power supply turns on, there's a sudden spike that goes right from the emitter to the base, and it exceeds 6 volts by quite a bit. An unmeasurable amount. Well, on my Fluke with it on min max, or maybe just trying to look at the screen, it's unmeasurable. Anyway, so I've clamped it with 4 diodes. The reason there's so many diodes is because with less of them, they're closer to conducting and they have more of an effect on the tempco of this transistor. With this many of them, they're still clamping at around 2.5 volts because it's bugger all, it's a short spike and it's a very low current. So clamping very early, and fast. These diodes can go up to like 1.1 something volts under load, like 10 plus milliamps. They're all in series and they're clamping at about 2 volts. So this transistor's got a breakdown voltage of 6 between the emitter and base. In reverse, it's clamped at about 2 point something. What else? What else? I think that's all for now. I've just been playing around with this panel meter, trying to work out if I could actually do something about it. It's just not hooked up at the moment, if you're wondering why there's nothing on the screen. There's nothing terribly wrong here. 731. What's going on there? Oh yeah. I've hooked it up at the wrong spot. I do these things when I'm getting tired. There, 732, 731. So let's see. It's literally bang on. It's exactly in behalf. Yeah, it's like right on. There's a bit of contact resistance going on here. So, yeah, really impressive. I'm happy with the panel meter, just not a noise problem. So, other things I have done. I had another little 12 volt regulator mounted in here, just sitting down in here. I was running the panel meters off that. Then I realised how stupid that was, because all those regulators running only warm, I wouldn't want to put a big load on it. These draw nothing. So I don't even know why I did that, but I pulled it straight back out when I thought about what I was doing. And I'm running them off that regulator. Excuse me. I've done a few little things for isolation on the case, because for really good cooling, these transistors are bonded straight to the heatsink with thermal compound. There's not even micro insulators between them. Therefore, the heatsink can't touch the case, because the collectors would be then bonded to earth. So the heatsink's got, I don't know if you can see underneath it, some black plastic electric insulating card and a few layers of very thick Kapton tape on top. It's bolted to the back via a plastic fan, and none of the bolts touch the alloy. I've cut out around the side, so there's no way that can touch the chassis. Transformers, like I said, star grounded basically and bolted to the case, but it's also got foam all around it, if you haven't noticed. So if it hums, the whole case doesn't start going zzz, because that'll be quite annoying. That's all there is to give you as an update for tonight. I'm tired. I was going to do more work than this. I've been fixing phones, picking up components today, doing other stuff. By the time I started working on this, I just got through a couple of things and started getting tired. I thought, man, I said I was going to take a video for a couple of days, so I thought I'd take a video quickly and show you guys what I'm up to, but I'm not going to design an op-amp buffer tonight for that negative rail for the panel meter. I'll do that tomorrow, and I'll upload another video on that. But as you can see, 814, it's just yeah, it's not an accuracy problem. Really happy with that. I feel like I'm missing something, but oh well. I'll put it in the next video if I do. Alright. You all take care. Leave any comments. Please like and subscribe. And I don't mention that. I'm not one of those people that likes to beg, but obviously it's going to help my channel grow. I am obviously going to get microphone, cameras, all that sort of setup, bit of lab lighting. This lab's actually getting torn apart pretty soon and a proper one built. This is all just made out of literally bits of wood. Milk crates, tables, the floor's screwed up in here, had termite damage. There's no termites now, but the floor's screwed. The walls are screwed. They've been touched for, I don't know, years, 20 years. Yeah, so the lab will get redone soon as well. There's going to be a lot of videos to come on different things like the lab, progress of this, low noise amplifiers, products that I've got arriving, fixing this multimeter, projects that are up on the whiteboard, components. As you can see, the collection's still growing. It's always growing. I still got to get through all of this. Yeah, that's about it for now. You guys have a good time. Peace.